Hi guys, so today I wanted to go over some of the very interesting facts that goes into scuba diving as well as a little bit of the science that goes into scuba diving. So let's just jump right in. So what is diving? Diving is just a basic term for going underwater. Usually diving entails going deeper than 3 feet. Diving has also been around in Greece since the 14th century BC, at least from fossil records and different writings. This is what most historians can gather. Before any of the fancy equipment, most people would just hold their breath for as long as they could. This is something that is now formally called skin diving or free diving, and there's actually a world record placement for this as well. I believe the record stands at 230 something feet, if I'm not mistaken. Also, in these times, it was also recorded that divers would flip over cauldrons, placing them underwater as diving bells. So, if you've ever experimented as a kid, taking something as simple as a cup, flipping it upside down, and plunging it underwater, you'll notice that there's going to be a cavity of air that stays between the water and the bottom of the cup itself. So people back then, they understood this and they use this to go diving, especially for things like clams, lobsters, and different types of sea creatures, crabs. Now that we have a little bit of the background, we can discuss the evolution of modern day scuba. When people think of scuba, they think of a tank and an air source, and that's more or less the truth. Modern day equipment consists of a scuba tank, regulator, pressure gauge, and an alternate air source. Of course, there are some scuba kits that have more things, some have less things depending on what you're doing, but that's gonna be the kit for a recreational diver. Technical diving is completely, totally different. It's in a completely different realm from recreational diver. I recently became a recreational diver. I've been diving for the past couple of months now. I linked a video down there you can see highlighted in blue, and this is where I show my personal equipment and I detail everything, what it does, where it goes, and stuff like that. So now that we've taken a look at a little bit of the history and the kit itself, we can start to understand the different relationships. The most important relationship that a diver has to know 110% is going to be between pressure and air mass. So if we look at the first table, we're going to have the atmospheric pressure on one side and the depth on the other. And the relationship is for every 33 feet or 10 meters, it's going to go up one ATA or 1 bar. This is also going to correlate to our second table, which is going to be the atmospheric pressure and the air volume itself. So as you can see here, volume gets affected very drastically. This is one of the reasons why divers cannot stay underwater for a very, very long time. Because even though the air itself is denser, the volume is what you have to pay attention to. And this relationship between the pressure and the volume also affects your lungs, as the natural airspace will expand and constrict when you're going underwater and when you're coming up to the surface as well. Then we're going to have the third table, which is going to show the relationship between the pressure and the air density. As you can see here, it's pretty much the same thing. So if you're at twice the atmospheric pressure, the density of the air is going to be twice as much, and so forth. So now that we looked at the tables, we can understand these relationships as a diver. And as a diver, understanding these relationships is 100% essential. It is your lifeline as a diver. If you cannot understand dive tables, if you cannot understand these relationships, you will not be able to dive effectively. Also, before a diver enters the water, there are strict calculations that they need to follow. These things such as measuring your depth, your air volume, and the time that you're going to be at depth before every dive, no matter the depth, is an essential necessity. Like I said prior, lungs work as a natural airspace, which expand and constrict with the pressure as well. There's a little model here at the bottom which shows a balloon that's inflated at the surface. When we bring it down to 132 feet, it is 1/5 of the size, and vice versa. If I inflate a balloon down at 132 feet and I bring it up to the surface, the air will expand. So as you can see, all of these relationships correlate to the amount of time you can stay underwater, how the breathing is going to feel, and of course, the pressure that is going to be acting on your body. Also, with diving, there's a lot of things that affect your body, and these are just a few. So as you dive, there is an excess of air molecules that accumulate in all your tissues. The most important that divers keep track of is nitrogen, or N2. Nitrogen in the body can lead to gas narcosis, which can lead to memory loss, hallucinations, and unconsciousness. Usually, the most dangerous aspect of gas narcosis is that when a diver is experiencing gas nitrosis, it can feel as almost a high or an out-of-body experience, and this can cause the diver to lose track of their depth, their air, and all these different things. And then also prolonged episodes of gas narcosis can lead to the more severe things, just as memory loss, hallucinations, and even unconsciousness. Also, when performing an ascent, gas in the body rapidly expands, which is one of the reasons which safety stops are a must when diving more than 33 feet. And a safety stop is basically where you give time for your body to acclimate to the changes in pressure on the body, and it allows all the gases in your body to naturally be able to release without putting much of a strain on your body. So now something that I have here in this is going to be the recreational dive planner. This is given to every diver. Right here we have the PADI recreational dive planner. There are several ones, but they all consist of the same model, or they're all created under the same model. So this dive table shows various relationships that a diver must know, like stated prior, the depth, the time, the nitrogen levels in your blood and in your tissues. So the first table is going to show the depth and time. Then the surface time interval, which is, like I said, your safety stop, as well as the time that you need to stay above the surface before your next dive. And then when you flip this dive table over, you have your third table, which shows what you can do for your second, third, fourth dive. But most of the time, most people that are going diving will usually do only 2 dives, 2, 3 max. Again, this also depends on what type of work you're doing or at what depth you're doing your work. Thank you so much for listening to my seminar. I hope that you guys learned something about diving and the relationships that each diver has to be aware of. At the bottom, I listed some really good references that I use for this seminar. I hope you guys have a good day.